and welcome everyone. This is part 2 of your OSI model. So let's get started the part 2 discussion in this series. So as of now we have covered about the OSI model basic, that why we need and the number of layers, and also we have covered about the application layer, we have discussed about presentation layer and session layer. 3 layers we have discussed. In this we are starting with the transport layer itself. So transport, at the name suggests, transport is all about the transportation of your data from one application to another application itself, is nothing but your transport layer job. See this, read this. It provides the data delivery mechanism between the application in the network. It's like computer, another computer. This computer A had some application, let's say application as application C, and computer B has the application C. So it is the responsibility of your transport layer to transport the information from application C to application C only in this particular computer. That is what the data delivery mechanism between your application in the networks. So transport layer provides the end-to-end encryption or end-to-end transportation of your data. Also you need to remember the major function which is performed by your transport layer is this. Read this. This is major function of your devices. First of all, identifying of your services in this particular network. It's like it is TCP service or UDP service is very important to identify. Then segmentation, sequencing and reassembling, and also flow control. This is the job into this particular transport layer. Okay. So segmentation is all about, let's say if you have a very big file, that particular file or maybe a data is going to break down into multiple pieces and then forward it to different computers now. So segmentation is nothing but a very big data is going to be divided into multiple, that is called segmentation. And sequencing is all about, it will assign the number, like this is sequence 1, 2 and 3 and 4, so that when each and every piece reaches to the particular destination system, your destination system will be able to reassemble the same in a order like 1, 2, 3 and 4. So segmentation is all about breaking down, sequencing is about the assigning sequence number, reassembling is all about assembling your data in a order. Flow control is like, let's say if I have received just, let's say I have received packet 1, 2 and 4, I have not received the third, so I can say that, hey, please give me the packet. Which packet? The packet number 3, and then it will send again, and that is called as flow control. So you will have this ability at transport layer itself. Okay. So transport layer is very important layer which is going to provide the data delivery mechanism between application in the network. And the major function, you can see the major function is all about identifying your services, whether it is TCP, UDP or what kind of services, then segmentation, then sequencing and reassembling, and also the flow control. This is the major job. Couple of points about how you can identifying the services. See, read this. Basically there is something called as port numbers, and port numbers are used to identify the destination applications which is running on the systems. Make sure transport layer identifies and define the port numbers to each and every services which is requested by the users itself. And you might have seen sometime, you might have seen like HTTP has the port number of 80, HTTPS has the port number of 443. Who has defined this port number? Basically these are the standardized port numbers. If anyone is saying port number 80 or port number 443, you can understand which service, HTTP or HTTPS. Same thing. The major point again, these port numbers are basically the logical communication channel, which is 2 bytes of address, 2 power 16. So total 0 to 65,535, in which there are some of the port numbers are reserved port number, like 0 to 49152 is going to be the reserved port number. Means these port numbers are already defined for some specific purpose. It's like for HTTP port number 80, For HTTPS, port number 443. For let's say FTP, port number 21. Like that, port numbers are defined for each and every protocols. But there are some open port numbers are also present, which is the range of this 49152 to 65535. This is open port numbers which can be used anytime for the application itself. So at the transport layer itself, how you can identify the services? By using the port numbers, which is of 16 bits of address, and where you have some reserve port number and you have some open port numbers as well. Next, how can you identify the port numbers which comes under the TCP and UDP? See, there are some standardized port numbers are present here. For example, is this. You have telnet service, for this port number 23, SMTP port number 25, HTTP port number, FTP port number 20 and 21 for server and client, DNS 53, HTTPS 443, SSH 22, POP 110, NTP network time protocol 123, IMAP 143. This is your TCP port numbers. Just for example, I have shown you this one. If you remember, at least this many port number is more than enough for the CCNA. But if you want more, go ahead and Google it, the specific port number for each protocols. If you can remember, that would be great. Similarly, you have for UDP like SNMP protocol, TFTP, DNS, DSCP has the specific port numbers. Now, the next point comes, what is this TCP and UDP now? Two things. As we know port numbers, that is okay, I can identify the services. But what is this TCP and UDP now? See this. TCP and UDP is basically the protocols, and these protocols basically runs on the transport layer itself. There are some differences in this TCP and UDP you will find. The major point which I can highlight about the TCP and UDP is all about this. Let's say you have the TCP. What happens in TCP? Let's say computer A and you have computer B. So let's say you have some data here that you want to forward. So normally in TCP connection, what happens? First, your PCs will try to establish the communication. It's like first they will go ahead and perform the operation so that they will negotiate that, hey, I want to forward some information. First, they will say, hello, I want to forward some information. It will say, that's okay, let's go ahead and establish. Means they are going to exchange some information and say that, hey, I want to forward some information. Other PC will say that, yes, I do, I can receive. Another can say, yes, go ahead. So it's like before forwarding the data, it is going to basically establish the session, and then it is going to actually forward your data in TCP operations. But when it comes to UDP, it's all about your one of the PCs can go ahead and forward the data to another PC directly. There is no session management, no session establishment. So it's like this is the operation. So in TCP, it will first establish the connection before forwarding the data. In UDP, it will directly forward the data. No connections will be established here. This is basic point. Okay, that's the main reason we have the different word that we call is that. So let me explain little more in this. See this. TCP, as I said, TCP provides the reliable and error-free data delivery between the applications which is running over TCP. Make sure it is reliable and it is error-free. Your TCP protocol is considered as the oriented protocols because it is going to establish the virtual connections before forwarding the actual data, and that virtual connection is called as TCP operation or three-way handshake. What is the three-way handshake? I will show you. So it's like three-way handshake is like this, A and B. Three-way handshake in the sense it will say that, hey, I want to send some information. It is saying that, hey, are you there? I want to send some informations. I want to open the connections, like that. So this message is called as sync message. Sync in the sense, hey, I want to open some port numbers to forward some information. If you agree, you will say that sync plus acknowledgement. Okay, I do want to open that. Then this is going to say that acknowledgement, that yes, I am ready to open. So it's like this is basically called as three-way handshake. Sync plus acknowledgement, and then acknowledgement. TCP connection has been established. Once it is established, now the data will be forwarded here. Okay. So this is very important to remember. Now, couple of points. It uses segmentations and sequencing for a reliable and ordered packet deliver mechanism. Complicated, slow in terms of your network usage, because it is going to establish the connections before forwarding your actual data. Three-way handshake, as I have already discussed in detail, is this. Read this. Sync plus acknowledgement, and acknowledgement. Sync is all about your sender is going to request for the connections and synchronizations. Sync plus acknowledgement, your receivers will reply that yes, I do want to open. Then acknowledgement, sender will acknowledge the confirmation and they will start the data transmission now. So it is all about sync plus acknowledgement plus acknowledgement. It is called as three-way handshake, or also called as TCP/IP operations. Now, next we have the UDP. As I discussed, UDP stands for your user datagram protocols, where there is no reliable packet delivery, no order of your packet delivery, and here there is no connection establishment, there is no virtual connection before forwarding the data. Directly data, see this? It provides unreliable data delivery mechanism between the applications which is running on the host. Connection less protocol, there it was connection oriented, here it is connection less, because it does not establish any kind of virtual connection before forwarding the data. There is no sequencing of your data and does not care about the order in which the segmentation is arrived. Does not provide the acknowledgement for the delivered messages. That's the main reason it is unreliable service. One of the major and important point to remember, it is very quick and efficient communications, because doesn't need to establish any kind of connection before forwarding the data. But the point is risky. It can forward your error packet, it can forward your bad packet, and also you may find the packet loss as well. No reliability. So TCP and UDP depends upon the scenario the protocols will be used here. I cannot say only TCP can be used, I cannot say only UDP can be used. Our organization can go for your TCP and UDP, both the protocols, based on the use cases. I hope it must be clear, guys. So this is basically, see, as a part of your transport layer itself, we had the discussion on identifying your services, right? Identifying your services where port numbers, and then TCP and UDP comes into the picture here. Fine. Now, after this transport layer, next we have the network layer. Again, couple of major points to remember. See, network layer is the major layer which we are going to deal with on daily life. See what happens. See, network layers describe how the data is routed across the network on the destination. And your network layer include two major functions. One is your logical addressing, second is your path determination and forwarding. Very important. What is this? In simple term, logical addressing is nothing but IP addressing schema. Your network layer itself is responsible to understand the IP addresses, which can understand for the router, for the switches, or maybe for your computer itself. When it comes to path determination and forwarding, it is all about from one source to reach some destination, there might be multiple paths. So this network layer has the function which is called as routing, that can have the best path selection as well. That if you have number of path in which is the best path, and that path will be used to forward your data. So logical addressing and path determination and path forwarding. This is two major things you need to remember, which is perform at network layer. Now, two things to remember. In this particular network layer, you have two different protocols which is generally used. One is your routing protocol, another one is your routed protocols. Routing protocols are basically like RIP, EIGRP or OSPF, which is basically used to determine the best path. This is basically used to determine the best path. And routed protocols such as IP, IPX and AppleTalk is basically used to forward your data. So these protocols like routing protocols are basically used to find out the best path, and routed protocols are basically carrier for the data. They will carry your actual data. Okay, so majorly nowadays you will find the IP only. IPX and AppleTalk is not in used. So make sure at the network layer there are two major protocols we have. One is your routing protocol, another one is your routed protocols, where routing protocols is used to determine the best path, and routed protocols is basically used to forward your data over the best path. So this includes your network layer. Now next is very important. The device which works on this particular layer is your router. Okay, so next layer comes your data link layer. Guys, make sure your network layers deals with logical addressing. Data link layer deals with physical addressing. See this, read this. While the network layers deals with the data moving across network using the logical addresses like IP address, but the data link layer deals with the data moving within the local network using the physical address. Logical is your IP address, physical is your MAC address, and each host has the logical and the physical addresses. Then only you will be able to perform the proper transportation of your data. Okay, responsibility which performs at the data link layer is this. Your responsibility is all about converting your packets into the frames is very important, and the hardware device which is used at this particular layer is this NIC, switch and bridge. These are the devices which is basically used at this particular data link layer itself. Okay, now last but not the least, we have the physical layer, and this physical layer is all about your physical cable and connectivity. See, it defines the electrical and functional specifications for the communication between your network devices. Okay, and the function which is described at this particular layer is this. First of all, coding and decoding. What is this coding and decoding? It is the process of converting your binary data into the signals based on the media and forward it to the different device. That is called as encoding. So make sure encoding is all about converting your binaries into the signals, and decoding signals into the binaries, and that is completely happens based on the media what you are using. Like if it is copper, then it will go for different voltage. If it is fiber, light pulse. If it is wireless media, then radio frequency waves will be theirs. So it's a physical layers. Now next comes one of the major point. Always remember, OSI is just for the reference, and this OSI model is being followed by each and every manufacturers, those who are into the networking devices, so that everyone can follow the same OSI model, same rules and same function, and every devices can communicate to each other. But the point is, OSI model cannot be used in the production. You know what? This OSI is just for reference, but in the production network we are using something known as TCP/IP layer or TCP/IP model. TCP/IP layer or TCP/IP model. Just try to understand now what is this TCP/IP model. Guys, is here. See, application, presentation, session, transport, network and data link. We know that these layers are basically considered as These layers is basically considered as application layer. These layers are considered as your network access layer. This is your internet layer, this is your transport layer, same thing. This is your TCP IP layer, which is basically being used in the production. Your devices are also using this TCP IP model only. If you want to verify, I will show you. Very simple. You can open your network and sharing center and see that network connection. See, for example, for me, this your NICs. Go to this and just click on the detail here, and not the detail, guys. Just give me a moment. Properties, and then you see here your IP version 4. Correct? No. Click on this. See. Oh, sorry. Sorry. What I was, yes, this one. See this. Click on this. Now see. Can you see here TCP IP version 4? You will not find the OSI here. In production, your each and every devices are using TCP IP layer itself. So make sure OSI is just for reference, but in the devices you will have the program of TCP IP layer itself, and it is nothing but same thing you will find as the different layer. It's like 1, 2, 3, 4 layers are there in the TCP. Fine. So for sure OSI was one of the big topic, guys, and it was very important to understand that we have. I hope you have got the idea of it, and thank you. See you in the next chapter.